Okay, welcome back to the chemistry lab here. What we're going to do next is we're going to do a little bit of a chemical changes lab. We're going to take a look at chemistry in action with a little bit of a chemical reaction. I'm going to do my chemical reaction in this teensy tiny beaker here. First off, I'm going to add a little bit of a compound. Remember what a compound is. Compound are two elements chemically bound together. And there it is, our chemical compound of copper 2 chloride. Copper and chlorine are chemically bound together in this particular compound. And we're going to need a chemical reaction to get the copper and the chlorine to break apart. Now, the first thing I'm going to do is I'm going to add a little bit of water. And, copper 2 chloride has an intrinsic property of the fact that it can dissolve in water, very similar to table salt, because copper 2 chloride is also a salt, believe it or not. And you can see here it is, my copper 2 chloride. It's got a nice blue-green color. Copper tends to be kind of greenish, bluish, and the color is a little bit different on the screen than it is in real life. It's a little bit more blue on the screen. It's got a little bit of greens in there. But here's my copper 2 chloride dissolved. This is not a chemical reaction. This is just a mixture. I mixed together a salt, copper 2 chloride, and water. And I'm going to take the temperature here of my copper 2 chloride water contraption using a thermometer. Okay. And as I measure the temperature, it looks like it's about 21 degrees Celsius. Okay, 21 degrees Celsius. And you might want to write that down. Okay, starts off at 21. Okay, the next thing I want to do is I want to add something that may or may not react with my copper 2 chloride. And I'm going to add some plain old aluminum metal. Okay, I used that in the lab the other day with the handle. I'm going to tear it into little pieces just like this, stick it in there, and I'm going to turn it around. You can see something's happening in there already. Okay, I'm going to use a little stirring rod here to push it under the water. Okay, and I'm going to use my thermometer to measure some temperatures. Wow, look at that. I've got some bubbling. I've got some color changes. And you can see kind of smoke coming up. Well, what is that smoke? That's actually steam. The water is getting so hot. Some of it is actually boiling. And you can't see this maybe on the camera unless I tilt it up a little bit. But the temperature is rising. Okay, I got a little temperature rise going on. You can see it shooting up. Now it's way up here in the 60 category. Shooting up even further and farther. You can see it's getting closer over 60, and it hasn't really been that long. Okay, going back down to the experiment itself. You can see that, wow, things are really different than they were to start with. Woo, that's pretty darn hot. I'm going to mix that in there kind of like this. I put a lot of aluminum in there, so there's a little bit of aluminum left over. But you can see that the liquid, which used to be a nice blue color, is not blue anymore, right? And we saw some bubbles and steam coming up. I want to pull out some of this stuff, and I'm going to put it on a little piece of paper. Some of the solid stuff that you see in there. Just like that. And you see our chemical reaction. And this is what it looks like, some of that solid stuff. This is what it looks like now. I zoom in and focus right in there. Looks very different. I can see that here's some leftover aluminum off to the side, and then here's some leftover aluminum that didn't react because there were just not enough stuff to react in. And then here's some new stuff that's coating the aluminum. It's kind of a rusty reddish color. Rust is iron oxide, and that would not happen because there was no iron in here at all to make iron oxide. So what is that red stuff? Well, if you think about the three elements that I put in there, and water doesn't count because water was the environment in which the reaction occurred, I put copper, chlorine, and aluminum in the speaker together. And a chemical reaction is when they rearrange themselves. There's usually an energy exchange, and you probably saw some indications of that energy exchange.